Pay attention, we got lots to cover here. Any PV solar system has excess power. If it didn't, it wouldn't be able to recharge the batteries fully. I mean, you just can't totally use 100% to charge the batteries and then supply whatever needs you are having at the same time. So there's always extra power that could be used for something, and this is a 300 watt inverter power supply that you can buy on eBay or anywhere else. It's ideal for a dump load. It's explained in another video, but now I'm going to show you how to hook it up as a system. If you can, let's get these meters up here. Right now we're at 12 volts. That's where I set the dump to. I'm supplying it with about 14 volts. As you can see, if I connect the power directly to the lamp, the inverter powers on fully and lights the lamp. This is a pre-charge resistor, we call it, and what that does is, I'll explain this later, it allows us to take normally 120 volt rated contacts and use them on DC without any problem. I'd be the first one to tell you not to use AC contacts on DC over 30-35 volts, that you'll start having problems. But this is a special case, and I'll explain that later to you. Right now I want to show the regulation. We're at 12 volts, and I keep climbing up the voltage, and you can see it's quite a good regulator. It's up there 31 volts, and it's still 12 volts on the supply. This regulator is doing that. If we change the setting, you can see that we can vary the voltage up anywhere we want. So it actually is regulating. Okay, let's move this stuff out of the way. This would be your standard PV system that you have already. You have a charge controller, battery, PV panel, and this is for a 36 volt to 60 volt PV string. I don't really recommend trying to heat water if you don't have at least that kind of voltage. So first thing we do is we isolate our system from the solar panel and the charge controller. This is very bad in PWM because the capacitors could supply an awful lot of current, much more than the charge controller is expecting, because they use a little trick, because the PV panels are basically current supplies and they're current limited. You know, if they say 10 amp control, they know they're never going to get more than 10 amps out of a solar panel. But if you put this capacitor there, it's kind of an unlimited supply. It'll charge up fully and dump in the power. So here's that pre-charge resistor we were talking about. If you look at the water heaters that we talked about and in the description, they're about 1500 watts. That makes this about a 10 ohm resistor for the heating element. And this system doesn't require any external thermostat. You can use the existing one on DC because we have this pre-charge resistor. It charges up the capacitor bank, and basically the voltage from one side of the switch to the other pretty much remains under 30 volts at any time. When these contacts open, these charge capacitors will supply power on this side, so this voltage doesn't really drop that much. And with the pre-charge, this capacitor will be probably at least 3/4 of what it will be when it's closed, so you're not going to see a massive amount of charge current. This is the resistor that supplies the power to the board. That's only about 10 milliamps, and that's not a major drain on the solar panels at all. So the tank will have 3 wires coming out of it for a 120 volt plug. You'll have a black, which connects up to the switching section. You'll have a white, which is on the other side of the heating element, and the green will normally connect to ground. But to make a clean operation, we'll lift this from ground. We'll put some heat shrink on it that's red or something, so people don't be confused that it's not ground anymore. And we'll connect it to the heating element on this side. That will go directly to the capacitor bank. Our inverter board has a couple FETs here. We tie those together, and that would be the white wire going to the tank. And the tank needs a ground, so put another ground wire to the safety earth ground on the case. How this basically works, we have, this capacitor bank is storing up these charges in between the on pulses of a PWM type controller. And so the normally we'll go up to open circuit voltage. These are listed on the panel. And what we do is we set our controller to the power point voltage, and anytime it's not charging, we're taking that energy and running it into capacitors. Basically the same thing works with a PWM, with a MPPT controller. Panels normally have a curve like this, and around the top, as it's moving around, it's not flat, but the power doesn't change that much for a couple volts. So all we need to do is set the dump load voltage just slightly higher than what it would expect for the power point voltage, and anytime the charge controller isn't drawing the maximum amount of current from the panels, the voltage will climb a little bit, and that current will go over into our system. So nothing is wasted. The 10 ohms, and we're looking at probably around 60 volts. It's 50 volts power point for around a 36 volt panel. So we're looking at 5 or 6 amps. So let's just say we're supplying 3 amps to charging the battery, and we got 3 amps extra we could do something with. So we'll get 3 amps of panel power, then probably get another 3 amps out of the capacitors, and that gives us 6 amps for the heater. It may not be a long pulse, but it'll be as long as it can be to maintain that power point voltage. Now, this is what we use for capacitors. We want to get around 10,000 microfarads. You'll see other systems that use little capacitors like this. Well, when the thing is doing an off voltage, these can't really supply enough current. It's like trying to use a 9 volt battery to start a car. These have internal resistance. They have a ripple current rating. Most commercial consumer type capacitors are only good for about an amp and a half of ripple current. These are rated for 3.6 amps each. So altogether, you can supply a lot of power out of this. And these are not going to heat up. These will be still working 15-20 years from now. These will have dried out, and you may not even know it, but you're not getting the efficiency that you once had. Now this diode, I like using these right out of a old PC power supply. This is a 30 amp 40 volt rectifier. You're never going to see a lot of reverse voltage, so the voltage doesn't have to be that high even if you were at 60 or 70 volts. And you can parallel up more than one. It doesn't matter. If you parallel them up, they'll share a little bit, but they will drop the forward drop voltage, so there'll be a little less heating. You get one of these power supplies, you'll get a couple nice heat sinks. You also get a case. Now if you look, you can fit these capacitors in there, and the board will fit right here. Just glue on a little block of wood, and then glue on the inverter board. Hot melt glue works. I know a lot of you are going to have trouble sourcing capacitors. These can be very expensive. I might put a TL431 starter kit having some of the other basic parts that if you ordered in quantities of 1 or 2, they'd be fairly expensive. And so I might, if there's any interest, I might supply those for US customers. And of course, you can mount this heatsink up top here somewhere. You get a switch, I mean everything you want, case. So if you go to a thrift store and you find one of these things at a garage sale, or can pick one up for $2, it's a good deal. So we've gone over the theory. These water heaters, if you get a 4 to 6 gallon tank, it really won't take that much to heat them up. And it's real nice to have hot water when you go to the sink. And in a small camp situation, this can generally add right on to whatever existing solar panels you have, and you'll capture that extra energy, and it'll heat some water, and you can probably have enough to take a shower. One thing you got to look out for is a lot of these tanks aren't insulated very well. If you build a box, or at least insulate the back of these wall mount units, you'll cut down some of the heat loss. Normally it's like 50 watts an hour that you can lose in a water tank. So cutting that down, trying to keep the water, so I have a 9-gallon tank on my system, and in the morning it's around 85 degrees, and by 11 o'clock it's up to 120 degrees, and we can operate the dishwasher. Yeah, we even have a dishwasher with heated dry. You can do a lot of things if you're creative with solar. If you go through inverters and everything else, you'll waste time. So this is my suggestion for the day, and you can get hot water free with your existing system for not a lot of expenditure. We're talking probably under $30 for all the electronics. The board itself is only $5. Look back in my previous videos, and that'll give you a sense of what's happening. You're not going to get it all at once. Anything I put on the internet, a 15-year-old could do. Of course, 15-year-olds are adventurous, and they're not worried about failing. As you get older, we see potential problems with things, and we're not as eager to take on a new task. But when we're born, we know nothing, and it's only us who decide whether we stay that way the rest of our lives. This is something you can do. I'm here to help you, so give it a try. Thanks for watching.